This is still 13.7, yeah. It's actually kind of the beginning of 13.7. What we did yesterday, I called it 13.7, but technically it was kind of written in 13.6. So, yeah, it's section... Oh, that's a little thick. Let's go down like this. Well...
You gotta finish writing it.
Say what? I gotta finish writing it in that same thing? Well, I was gonna get rid of it. I guess I can deal with that. Section what? 13.7. All right, now I'll switch it. Is that all right, Allie?
That's alright.
Thanks. All right, so what we're gonna do, if you remember yesterday, I'm not gonna put it up here. I was thinking about doing that, but if you remember that circle, remember we did 0 degrees. We found the cosine and the sine of 0 degrees and all that kind of stuff. Do you have that in front of you? Did you write any of that stuff down? Let's take a look at it. I'm going to refer to it. I won't actually pop it up here on the screen, but it would be nice if you had it in front of you. If not, it's in the book. Tell me what page that is. 850. It's on page 850. Some of you guys took notes on this yesterday. If you have that out, that would be good as well. All right. I just don't think it's going to be that easy for me to just switch from screen to screen. We'll just have you refer to it, okay? So what we're going to do, let's do the sine first, okay? So let's find the sine of those special angles. What we're going to do, remember yesterday I said we're going to take that circle and we're going to clip it and we're going to stretch it out so it's long and it's on a number line. That's exactly what we're going to do right here. If you look at this axis right here, this is the x-axis. I broke it into 30-degree increments. You could also do this in pi increments, or it would be pi over 6 and so forth. But you could do this in radians. Again, just so that we're not so worried about converting from degrees to radians, I'm just going to stick with everything in degrees. Is that okay? But again, I just want to warn you that there will be a time where you'll take a class and it'll be in radians. A whole lot will be in radians, right? But again, I may do a little bit of both, but as far as graphing this stuff, for the most part, I'll stick with degrees. And today, anyway, let's say this. Let's just say today that we'll stick with degrees. There may be another day where I'll throw in a radian just to kind of show you how it works, okay? All right, so anyway, let's do this. At 0 degrees, we're doing the sine, right? Is that what I said we're doing? Yeah, so we're going to do y equals the sine of, you could call it theta. Sometimes they just say x, right? I called this axis theta. It's kind of small, but you can see right here, call it theta. This is your y-axis. This is your x-axis, or your theta axis, if you want to call it that. This is the angle, right? And this is what the value of the sine of that function is. So let's just start with 0 degrees. That's the easiest place to start. So let's do this. I'm using a different system to write with. It's a little more jaggedy, isn't it, than the other one? The other one's a little bit smoother, but that's okay. So at 0 degrees, I'm not going to do this for all of these, but at 0 degrees, what was the sine at 0 degrees? It was 0, all right? So I'm going to put a little 0 right there. At 30 degrees, that was, in fact, at least the first quadrant anyway, you should be able to do this in your head. At 30 degrees, that's the angle. It's a little bit flatter, and the sine is the up and down one. So what is that one? At 30 degrees, it's a half. So again, I'm going to try my best to get this to be accurate. And then we did 45 as well. 45 was square root of 2 over 2. Punch that in a calculator to see what you get for square root of 2 over 2. Now this is going to be an approximation as far as me on here. It's like 0.71 or something like that, isn't it? 707 or something? Yes? Okay. So where do you think? There's 45 degrees. I have to kind of, I'd say about right in here somewhere. Is that about right? About 0.7? I don't know. We'll say. All right, what about 60 degrees? What's 60 degrees? Square root of 3 over 2. And push that in a calculator. It's like 0.86, I think, is it? Do it real quick. Who's got a calculator? Luke, you getting it? 0.86? Okay, so 60 is 0.86, so that's about right here. So you see where the 1 is, don't you? So at 60 degrees, it's 0.86. I would say about round in here. That's pretty close, isn't it? All right. Do you see what we're doing? We're taking that circle and we're spreading it out. So we're finding the sine of all these different angles, plotting it on a straight line, x and y axis, and then we're seeing what this thing looks like. It's not going to be a straight line, is it? You can see what's it starting to do. Starting to curve. What do you think? Do you think it keeps on going up? Let's see what happens. So what's the next one? We had 60 degrees. Let's go 90 degrees. At 90 degrees, that's up here like this. At 90 degrees, that's 0, 1. So what's the sine of 90 degrees? It's a 1. So again, where do you think that is? Is that about right? About right there? Okay. Let's keep going. Now, we're not going to do this all day long, okay? We're just going to kind of get you an idea of what we're trying to do, and then I'll show you the nice smooth graph that the computer program drew. And it'll be a lot better than me trying to do all this slop, especially with this marker, okay? Let's go 120. Look on your thing. What's 120? The sine of 120. Square root of 3 over 2, which is at 0.86. And if you look at this, you can kind of see the relationships. Do you see that? It's a mirror image with the other side, except it's going the other way. Does that make sense? All right. What about let's see, 100. Let's just go. Well, that would be what, 135, right? So I don't have a 135 in there, but it's halfway in between these two. So that would be square root of 2 over 2, which is that 0.7, which would be, I don't know, about right in here. Then 150 was what? Was a half. All right. And then 180 is 0. Do you see that? Look at that. We got a nice curve like this. But does it stop there? No, it keeps on going, doesn't it? Let's do some more. Let's just do some main ones. We did all the in-between ones in here. Let's just do the ones that are right on the axis. Make it a little easier. So we already did 180, which was 0. What about down here at 270? So let's go to 270. What's the sine of 270 degrees? It's negative 1. So 270, I'm going to come down here. Tell me if you think I'm lined up. I don't have any lines or anything. I could put grids on here, and I should have done that, but is that about right? Pretty close, right? All right, and let's go around. So we did 0, 90, 180, 270. Let's go back around. Where would we be here? At 360, right. That's all I'm just asking, just to make sure everybody's following along, okay? That's all. So 360. Again, what's the sine at 360? That's 1, 0. So at 360 and at 0, it's the same thing, isn't it? And guess what we do? We start that whole thing over again, don't we? I could have put those in between ones, but you see how they would follow here. You follow me on that? So I could have put square root of, let's see, I would put a half, square root of 2 over 2, square root of 3 over 2, and it would fill in all those little gaps right here, and you could see that nice smooth curve. Just don't want to take the time to do all that stuff, but I could do that. Does that make sense? All right. And now if you wanted to, you didn't even have to use the exact ones. I mean, you could have used, like, 17 or 15 or 27 or 38 or something like that, but that would just be kind of weird. We're just using the ones that the common ones that we're used to. So what does our graph look like? Now, I'm going to try. This is why I use this computer program. I'm going to try to connect them. So it's going to be like this. Let me pick up my pen. Oopsie daisy. Anyway, you can see. Oh, I was supposed to hit those points. Now, what's it going to do here? It's going to kind of curve the same way down like this. That's not too bad, actually. It's better than I thought it would be. Do you see what's going on? Then does it just stop right here? No, because it's not that I can just go one time around the circle. I could do what? I could keep going around. That's why you have angles that are larger than 360. Does that make sense? Because this represents that you're going around the circle a bunch of times. Okay? And that's what we're doing right here. We're taking that circle, okay, all the trig functions of that circle, and we're translating them to a vertical, or to a horizontal and vertical axis. And it stretches out like that. Okay? That's the sine curve. That's what the sine looks like right there. Okay? We call these in general, we call them sinusoids. Sinusoids. It's kind of weird. Even the cosine, we call a sinusoid. All right? So that whole basic taking the circle, stretching it out into an x and y axis like this, that's called a sinusoid. This particular one is the sine function. Notice what it does. Now, of course, it could go negative as well, couldn't it? You can go this way around here. So I could start putting points negative. So watch, if I go to negative 90, where's negative 90? It's the same place as 270. Where's 270? It's at negative 1. So at negative 90, I could come down here to negative 1, and it starts that whole routine all over again. Do you see it? And I could come over here. This is 360. 90 more would be what? 450. At 450, or at 90 degrees, what's the sine of that? It's at 1. Do you see it? So really, you don't have to put in all these little points. Really, it's these key points, those quadrantal points right here. This one, this one, this one, and this one. If you can graph those, you can graph these things by hand. You don't have to put all the little individual ones in there. I just did that just to show you that it does make a nice smooth curve. It's not just straight line, from here to here. It goes off in a nice progression all the way up, and it progresses all the way down like this. Does that make any sense? Okay. Now what I'm going to try to do, we'll give this a shot. This is where it gets a little tricky. I already graphed these things on the program. It took me a while to figure out how to do it, but I think I figured it out. So we're doing the sine, right? So watch this. I'm going to click on that, maybe. Ooh, look at that. See the blue one right there? That's not too bad, is it? It's a nice smooth curve, and I'm going to show you something else that's kind of cool. Let me get rid of all that junk that I just wrote. Clear the page. There we go. Now we got a nice pretty picture, and you can see that nice smooth curve. Do you see it? 0, 0, 90 and 1, 180 and 0, 270 negative 1, 360 0, and it just starts the whole routine all over again. All right? I'm running out of time. Thank you very much.